Recently, we started making a devlog series about how I optimize my indie game Wisplight. From our previous devlog, we talk about how I utilize spawners to spawn objects in our scene when we need them, improving our performance. And in this video, we'll be talking more about object pooling and how they work in my game Wisplight. I'll also be showing my code by the end of the video, and we'll be discussing how they work in my game so that you guys can copy and utilize them in your projects as well. Just a disclaimer though, I don't have any previous experience in making games or have any formal educational background about programming, Unity, or making these games. I just learned all of these from the internet. I don't even know if what I'm doing is right. I just research and experiment on these features and gravitate towards what's working and fix the things that are not. So forgive me if I'm doing some of these things wrong. I just want to document and share my thought process in my game development journey in making Wisplight. So for those of you who are new here, I'm June and I'm making my first indie game Wisplight. It's about a wisp who can transform into different monsters with different playstyles, and your goal in my RPG game is to fight and eliminate human settlers invading and exploiting resources from your island home. Basically, it's a reverse RPG where you play as the monsters instead of the usual RPG heroes that we play, and I make devlogs on my development progress. If you want to follow the development of my game, feel free to subscribe to get updated. Let's begin. So what's object pooling, and why do we need it in our game? Object pooling is a fundamental optimization technique used in game development, especially in scenarios where you have to instantiate and destroy objects frequently. Imagine if you have enemies in your game, and when you hit them with a sword, you want blood splatters to appear. Every time you swing your sword, you might want to instantiate a blood splatter effect. However, creating and destroying these effects every time can be resource intensive and can affect your game's performance. Here's where object pooling comes in. Instead of creating and destroying blood splatter effects all the time, we create a pool of these effects at the start of the game or when needed. So when you hit an enemy, you're not creating a new blood splatter effect, you're just activating one from the pool. When it's no longer needed, instead of destroying it, you just deactivate it and put it back into the pool to be reused later. This way, you're avoiding the overhead of constantly creating and destroying objects. Let's set our blood splattering mechanic as an example. Think of it like having a supply of blood splatter effects ready to go. When you strike an enemy, you grab one from the supply and display it when needed. Once you're done, you simply put it back into the supply for future use. In Wisplight, I use object pooling for various game elements like blood splatters, enemies, interactable objects, and visual effects. It helps maintain a smooth and immersive experience without compromising the game's performance. Now let's delve into the code and see how object pooling is implemented in Wisplight. Let's take a look at how we use object pooling to show some visual effects. Let's experiment on this explosion effect from our torchbearer when they hit us with their torches as an example. But before that, let's check the code first for my visual effects object pool. So here's my code for our visual effects. Basically, I designed it so that I can make as many object pools as possible with an additional feature that lets you add more than one prefab for the game object that you are spawning. For instance, this blood splatter effect where we have multiple prefabs to choose from to create a more diverse blood splattering effect. But for now, let's simplify it for demonstration purposes and just talk about the fire hit effect, which has only one explosion effect prefab. So currently, we have all of these object pools in our game. And I can add more if I want to by just clicking the add button below. This will create another object pool to be added to the list of object pools. Then inside this list, we have our object pool, which consists of the pool name, which will be a reference to this pool when we need to get objects from it later on. Then we have our prefabs, which are the game objects that we will spawn when we need them. And this is also a list where we can add multiple prefabs for us to spawn for diversity, just like the blood splatters. Then we have the deactivate after seconds float value, which functions as a timer to when the prefab is active on the scene. Then after the time passes, it will deactivate the prefab and return it to the pool. Then lastly, the pool itself, where we store the created prefabs that we will be reusing in the scene all over again when we need it. So to further demonstrate this feature, let's test the torchbearers hitting us. So as you can see, when the torchbearer hits us with the torch, it spawns the explosion effect on the position where it hit us. Then, as you can also see here in our pool, it gets added to the list of objects in our fire hit pool. Then after 2 seconds, which is the timer that we set on this object pool, it deactivates. Then, when we're hit again by the torch, it activates the same game object and positions them to where they hit us, recycling the game object. There are cases though that the torches will hit us more than once within 2 seconds. In this case, the game object that is spawned first is still active, so the object pool has to create a new one to display that effect. This in turn duplicates the explosion prefab, giving us another object in our fire hit object pool, which you can see here. There are already 2 of them, and these 2 will be recycled when needed. And again, if in some cases that we need another explosion effect while the 2 is active, the system will just create a new one and store it as one of the objects in the pool ready to be reused just like the others. This is very useful performance-wise, since we no longer need to instantiate and destroy after 2 seconds for every time the torches hits us. We just simply take an object from the pool, then move it to the position where they hit us. Then after 2 seconds, deactivate it and reset it, ready to be reused again when needed. So to translate this into code, I'll run you guys through the process on how this works on the script. So here we have our object pool, which consists of the things that I showed you in the inspector. We have our pool name, our list of prefabs, our timer in seconds, and a container for the objects that we are pulling called pool. Then we have some functions here to take note of. We have here getObjectFromPool, which is a function that we will call anywhere in our game if we need an object from our visual effects object pool. We also have our deactivateAfterSeconds function that will deactivate and return the object to the pool after the timer that we set in the inspector is reached. We also have a function to deactivate the game object called returnObjectToPool. And lastly, we have our getNextPrefab function that will randomize the spawning of prefabs when we have more than one of them, just like the blood splatter effects. So let's run through the code, starting with the function getObjectFromPool. So here we have our script when the enemy hits us with a torch. And I called the function getObjectFromPool and included the parameters needed, which is the pool name, in this case fire hit. Next, I also added some transform position once we get the object to position the object to where we hit them. Then, on our getObjectFromPool function, it will select the pool with the name that was sent, which is fire hit. Then from that, it will select from its pool an object that is not active and activate it, and return it as a game object. In cases that there is no object in the pool and it returns nothing, it will select a prefab and instantiate it, then add it to the pool. This will be the first object in the pool that will be reused every time we need this type of game object. After activating or instantiating a new prefab, we then run our coroutine that handles deactivating it. We just need to pass the object that we've spawned, and the number of seconds for us to deactivate them, which then is passed to this coroutine deactivateAfterSeconds. Basically, this coroutine will just wait for the seconds indicated in our inspector, then call the returnObjectToPool function, which basically sets the object past to inactive. So let's demonstrate it step by step again with the codes. So first, the torch hits us. It calls the function getObjectFromPool. Then we set the position to where we want the object to be spawned. Then the getObjectFromPool will check if there is an inactive game object from its pool. In this case, we don't have one yet, so it instantiates one for the first time and saves it to our pool. Then it runs the coroutine that deactivates the object once the timer is reached. And if the timer is reached, it returns the object to the pool, simply deactivating it. Then the cycle continues, but this time, instead of the function instantiating a new object, it simply checks first the list of objects in the pool and checks if there is one inactive. In this case, there is one, since the 2 seconds timer already passed. So it uses that object instead of instantiating a new one. Then the step continues and deactivates it after 2 seconds. Plain and simple, and it works. There are cases though that there is no available object in the pool since the previous one is still active, so it just instantiates a new one and saves it to the pool once again for future use. making 2 objects now available in the pool where we can recycle anytime needed. I hope you understand how object pooling works. If you have some questions, feel free to comment down below, or better yet, join our Discord server. If you have some feedback and suggestions to make this system better, please let me know. I'm still a beginner to game development, and I would really love to have someone to give me some tips that will make my code even better and the features even better. By the way, if you haven't, and if you're interested in our game, we are already live on Steam, and wishlisting our game will really help us marketing our game later on when we launch it on Steam. We will also be doing some combat demos soon on our Discord server, so if you're interested, join us on Discord and let us know. Major thanks to my patrons for supporting the funding of Wisplight. Without you guys, it would be very difficult for me to make this game. Having no job at all and working on this full time, your support really helped me a lot. For those of you who wants to support Wisplight, I'll leave a link to our Patreon page below. All the funding raised will be used in acquiring assets for your game. In our next devlog, we'll do some more deep dive into more optimization techniques that I use in our game. We will talk about level of details, or LODs, and how they work in our HDRP project Wisplight. Till next time.